Hello, welcome back to another AP3 video, and in today's video we'll be going over SAT math questions, more specifically one variable data distributions and measures of center and spread. We're going to be doing easy, medium, and hard questions, 4 of each section, so let's get started right away. So 5 A-type of sea turtle each have a nest. The table shows an original data set of the number of eggs that the turtle laid in the nest. A nest with six nests with 121 eggs is added to create a new data set. Which of the following correctly compares the means of the two data sets? Okay, so we gotta obviously analyze the information that's given. So I'm given that there's a 6 nest that is 121 with the nest that's given in the graph, and I'm given 5 nests: 149, 144, 148, 136, and 139, and we're gonna have F if we add the 6th one, which would be 121. And we're looking comparing the means of both data set A and data set B. Well, we can do one of two things. We can understand the rule, or we can plug in numbers. Let's understand the rule first, and let's plug in numbers to make sure that corresponds. So if we look at F, we can see that F, or the 6 nest, equals 121 eggs. So we're adding a number, obviously. And as we can see, the number is smaller compared to the other eggs. The only number that's closest to 121 is 136. Therefore, because the 6 nest is smaller compared to the other numbers, I can already assume that the original mean of data set is greater than the mean of the new data set. Therefore, my answer is going to be A. But let me plug it in, all the numbers, to make sure to do it correctly. So to find the mean, we always do adding all the values. So adding all values together divided by numbers used to find all the values. So for example, to find my mean for the original data set, I'm going to do 149 plus 144 plus 148 plus 136 and then plus 139. And because how many numbers we're using? 5, I'm going to divide everything by 5 to look for my mean. Now, good thing about it is that you can plug it into a calculator. So you can use Desmos, or you can use your graphing calculator, depending on what you use, which is always convenient because doing this math mentally takes a little bit of time. And you get roughly, if you do 716 divided by 5, roughly 143.2. And if you do if you find the one for the new data set, so it's going to be 716, the numbers that we add up together, and then plus 121 divided by 6, that equals, so let me get that same number group really quickly, plus 136, plus 121, and then divided by 6, we're going to get a data set, or a mean, of 139.5. As we can see, the mean of the original data set is greater than the new data set, therefore my answer is A. So it does correspond. Okay, let's do another question. The number of arcs of useful timberland in 13 countries in California is summarized in the box plot above. Which of the following is the closest median of the arcs? So it kind of looks like off, but basically I have, a range that's going from 1,000 all the way to 13,000, and we're looking for obviously the median. Well, the good thing about these type of box plots is that the median is always the line that's the bottom line. So for example, let me redraw it over here, right? Kind of looks like that. And if I have a line corresponding here, this is always the median, regardless of where it is. These type of graphs cannot give mean. So median can be given, the range can be given, which we'll go over it in a later question. However, we cannot find mean because we don't know how many values we have for each. So we can solve for median because median is the median number. So what we have to do is find the rough estimate or where the median is. So if I draw a line from a median, roughly, I get a number between 7,000 and 8,000. So let's compare my answers. A is really off. B does correspond. B is greater than 8,000, but it's not in the margin of 7,000 and 8,000. So B is crossed off. Oh, sorry. B is crossed off, not C. Don't know why I did that. Let me erase this really quickly. So B is crossed off. And then C, 10,000, that's too much. Therefore, my answer is B. Okay, the table shows the land area and square kilometers of the 5 smallest countries of the world in 2016. Based on the table, what is the mean land area of the 5 smallest countries in 2016 to the nearest kilometer? So, for this type of question, what are we looking for? We are looking for the mean. And the mean is the average. So, mean equals average. And like we did in the previous question that we did earlier, that's the total value of all the numbers divided by all the numbers used. I'm just gonna do a hashtag for numbers, right? So I'm given 5 numbers, 2, 21, 61, 26, and 0.04. So what I want to do is add all those numbers and divide the amount of numbers used in this question, which is 5. And I'm gonna look for my mean of the 5 smallest countries in 2016 of the land area in square kilometers. So what I'm gonna do 2 plus 21 plus 61 plus 26 and then plus 0.44 or 0.44, sorry. And if you plug that in again into a calculator, because doing it mentally kind of sucks, so then 61, 26, and then 0.44, you're gonna get 110.44 divided by 5. That roughly gives you 22.088. So all these numbers divided by 5 equals roughly 22.088, and we're looking for the number to the nearest square kilometer. Therefore, we round it up to nearest, like, ones place. It'll be 22. Therefore, my answer is going to be B. Okay, let's do another question. I have 4 4s, 3 8s, and 2 13s, and we're looking for which of the following tables shows the frequency representing the data listed. So let me write the information given. I have 4 4s. I have 3 8s, and then I have 2 13s, right? So what does frequency mean? It just means how many numbers are used. So if we look at 4, I have 4 4s, and if I look at 8, I have 3 8s, and if I look at 13, I have 2 13s. Frequency is not the total value. What I mean by that is, like, if I add all the 4s together, I get 16, 8's 24, 13, 26. That's what we're looking for. Frequency is just the total number used, total amount of number used, right? Keep in mind, this is really important, right? Because a lot of people think frequency is like adding all the numbers together. That'd be your frequency. No. Frequency is just a list of numbers that are used for that specific number. So let's look at 4. If we look at 4, I have 4 4s. So let me look at every single answer choice that doesn't have that, which will be C and D, because our frequency for D is 4, but our number is 16. That doesn't make sense. Our number is 4. If I look at C, my number is 4. I have a frequency of 16. That doesn't make sense either. So C and D are incorrect. So let me look at B now. If I look at B, I have a frequency of 4 and number 4 that corresponds. I have the number 3 and then the frequency of 8. That is incorrect, because remember, we have 3 8s, not 8 3s. So B is incorrect. Therefore, my answer is A. But let me make sure that all the numbers correspond. I have the number 4, and there's 4 4s, so the frequency is 4. I have 3 8s, so the number is 8, and the frequency is 3. I have the number 13, and I have 2 13s, so my frequency is 2. So the numbers do correlate. Okay, let's look at the information. The table shows the distribution of ages of the 20 students enrolled in a college class. Which of the following gives the correct order of the mean, median, and mode of the ages? Okay, so let me go through all the information given. So remember, frequency means the amount of numbers used, and that'll be important. So what is mean, mode, and median? Just to go over, remember, median's average, like we went over. Median's like the middle number. So therefore, if I have, let's say I have 1, 2, 3, my median's gonna be 2 because it's the middle number. And the mode is the number that is used the most. And you'll see why that's important too. So the 3 M's, remember, mean, average, median, the medium number, and mode is just the number that's used the most. So let's solve for the mean first, right? I'm given that there's 6 18s, 5 9s, 4 20s, 2 21s, 1 22, and then 23 and 30. So I gotta add all those numbers together to figure out my mean, And then we got to figure out how many numbers are used to, in this type of question, to figure out how many numbers are used so I can figure out the mean. Sounds a little bit confusing. So we would write the total value. It would be 18 multiplied by 6 plus 19 multiplied by 5 plus 20 multiplied by 4 plus 21 multiplied by 2. And then we'll have plus 22 plus 23 and plus 30. So let me add all those numbers together. But first, before I do that, I want to see how many numbers I'm actually using. So I do 6 plus 5 plus 4 plus 2 and then plus 1 plus 1 plus 1. I'm going to get 17 numbers. So all the values on top divided by 17. And if I plug that into a calculator, the information above, which is a lot, so give me some, this is going to take a little while. Then the 5 in parentheses. And make sure, when you're doing these type of problems, make sure that you're writing correctly in your calculator or Desmos. And if you can do it mentally, then do it too. But make sure you do it, you do it correctly, because one mess up in these type of questions can lead to it getting wrong. Right? You're going to get a number of 400, and then 400 divided by 17 roughly gives us, if we round it up, we're going to get 23.529, right? So this is our mean. So let me solve for median. If there is 17 numbers, I just got to count from all the numbers and land in the middle, which the middle number will be roughly between like 10 and then 17. So let's go through it, right? I'm going to have 3 6s. So roughly, what I like to do for these type of questions is just draw it out, the 17. So let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And you might be asking, well, why am I drawing it out? Well, remember, the median is always the middle number, right? So if I have the middle number, I should have an equal amount on the left side, on the right side. So if I circle this one, for example, I should have the equal amount on both sides. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Therefore, my median has to be the number that has 9. So let's count it. If I go from 8 to 19, I see that 9 lands in the frequency of 5. Because if I count from smallest to biggest number, which is how we look for the median, I'll see that my 9th number is going to land on 19. Therefore, my median equals 19, because when we count median, we go from the smallest number to the biggest number, and it will be in the middle. And therefore, because 9 is my number that will be the median, and the frequency, and then 19 relatively gives us the 9th number, that means our median equals 19. I hope that makes sense. And our mode, like we said, is the number that is used the most, and in this case, it will be 18 because our frequency is 6, meaning that 18 is used 6 times, like we said. So our mode is 18. So let me compare all my 3m's and see which one's bigger or smaller. As I can see, my mean is the biggest, so our mean is going to be in the front. And which one's my lowest? The mode. So the mode is less than the median, and median is less than the mean. Therefore, my answer is going to be A. And I went over it little by little to show you like how would you solve these type of questions, because looking for the median and just counting all the numbers might take some time. But if you know this general rule of like I'm doing all the tallies and seeing the middle number, that's what I like to do, which is what I showed my method. But obviously you can do your own way of figuring out the median. But in my opinion, when it's like a really small number like 17, 20, 21, or even like 5 or 10, that's exactly what I would do. Okay, let's look at this question. If A is the mean and B is the median of 9 consecutive integers, what is the absolute value of A minus B? Well, what is integer firstly? Well, integer is a number that can be negative or positive. It could be 0, but it cannot be a decimal or a fraction. So in this case, when it gives us 9 consecutive integers, what I like to do is just pick the easiest numbers that can represent 9 numbers. And that could be 1, 2, 3, 4, 5, like 1 through 9, because they are classified as integers and we just need 9 numbers. So we can do 1, 2, 3, 4, 5, 6, 7, 8, 9. As we can see, I have 9 numbers that are positive integers, which applies to the rule of integers and how they work. So A is the median, and no, A is the mean and B is the median, and we're looking for the values of A minus B. So let's look for the mean. So remember, the mean is always adding all the numbers and then dividing of the numbers that are used. So I'm gonna do 1 plus 2 plus 3, you get it, and 4, 5, 6, 7, 8, 9, and let's count how many numbers we're using. It'll obviously be 9, which this ultimately equals 45 divided by 9, which equals 5, right? So our mean, or A, equals 5, and that's all for the median. So the median is going to be the fifth number. Let's count 1, 2, 3, 4, 5. Therefore, my median is also 5. So B equals 5, and now I plug it into the rule or the equation that we need to use. So the absolute value of A minus B equals the absolute value of 5 minus 5, which equals 0. Therefore, my answer is 0. So remember, if we have A and B looking for min and median in these type of questions, it's always going to equal 0. Okay, we have a new key term, value. It's pretty simple to understand. So this question, you can literally solve it in less than 10 seconds. But let's understand it first. The table shows the frequency of the values in a data set. What is the minimum value of the data set? Okay, so we have a new key term, value. And value, it just represents the value of the number given. So 19, 21, 23, 25. And then frequency, again, is the number, how many times the number is used. Therefore, there's 7 19s, 121, 7 23s, and 4 25s. And this question can be easily solved because anytime that we're looking for the minimum value, this represents also just the smallest number used, which ultimately is going to be 19. So my minimum value equals 19. Be careful because a lot of people think minimum value is just, the number that's used the least. So it'll be 21. If they're asking for the minimum value frequency, that would be correct. But because they're asking for minimum value, the answer is 19. Okay, remember how I said we're going to go over range in a different question? This is it. So we're given the values of 23, 27, 27, 32, 35, 36, and 52. A lot of numbers. And we're looking for the range of the 7 scored and shown. So range is pretty simple to understand. Range is just subtracting the biggest number to the smallest number, and this applies to any information given. So we're given 52, we're given, again, 23, 2 27s, 132, 35, 36, and 52. So range, like we just said, equals largest number, I'm just gonna write largest, minus smallest. So let's see which one is our biggest and smallest numbers. Our biggest number is 52, and our smallest number is 23. All I have to do is just subtract it, and it gives me my answer, which ultimately equals 29, which equals the range. So my range is indeed 29 out of the 7 scores. And it's important to know this. And I'll explain how it looks like it in a box plot in another question following. Okay, now that we understand how value and frequency work, we're going to do a hard question now. The next 4 questions that we're going to do are all hard questions that pop up on the Module 2 math section. So let's focus and lock in. Dataset A and dataset B each consist of 27 values. The table shows the frequencies of the values for each dataset. Which of the following best compares the means of the 2 datasets? Okay, so we remember what mean is. Mean is just the total number divided by all the numbers used. And frequency is the number, how many times the number is used, and then value is just how much the number, like how much a number represents, like the value of it. So all I have to do now is just look for the mean and then compare them both. So let's look for the mean for data set A. I'm given that we have 2 30s, so data set A mean basically equals 30 multiplied by 2, 34 multiplied by 4, 38 multiplied by 5, plus 42 multiplied by 7, and then 46 multiplied by 9. And if you plug that into a calculator, so if you were to do 30 parentheses 2 plus 34 multiplied by 4 plus 38 multiplied by 5, and the other numbers too, 38 with 5 again, or sorry, I did a mistake here. 42 with 7. And then last but not least, 46 with 9. You're going to get a huge number of 1,194. So I'm just going to erase everything for space purposes. So this just equals 1,094. And let's figure out how many numbers are used in this question. So if I do 2 plus 4 plus 5 plus 7 plus 9, I'm going to get 27. So if I were to do 1,094 divided by 27, I'm going to get roughly a number, if we round it out to near its 10th place, of 40.5, which is the mean of data set A. So let's do data set B now. Let me do it in a different color so you guys aren't getting confused. I feel doing a little like a orange color right now. So data B mean. Remember, same concept, but just, different numbers. So in this case, we're going to do 30 plus multiply 9 plus 34 multiplying by 7 plus 38 multiplied by 5, and then plus 42 with 4 plus 46 with 2, and we plug that into a calculator. 30 parentheses 9 plus 34 parentheses 7 plus 38 parentheses 5. That doesn't change, which is very convenient, right? Plus 42 parentheses 4, and then plus 46 parentheses 2. I'm going to get a number of 958. So all those numbers adding up to each other equals 958. We're still going to have 27, or you're still going to have 27 numbers used in this question. So data set or data B mean equals 958 divided by 27. So if I were plugged into a calculator, if I round it up, I'm going to get 35.5. And this is my mean. So let me make that a little bit more pretty. This is over here. I'm going to get 35.5. So now let's compare the means. As we can see, obviously data A mean is greater than data B mean. So A is greater than B. So now we just gotta look for one of the answer choices that corresponds to that. So let's look at A. The data set of A is greater than B. That makes sense. Let's look at B. The mean of data set A is less. That does not make sense. They're not equal, and there is indeed enough information. Therefore, my answer is indeed A. You always want to double check just to make sure that you got it correct. Okay, let's do another question. The box plots below show the distribution of power of books read over the summer by students in 2 different English classes. What is the positive difference between the ranges of the number of books read over the summer for 2 classes? So we're looking for the positive difference between the ranges of books read over the summer for both classes, meaning the range of class A and class B. And that is important to understand, right? Normally, when you read the question, you're probably thinking, oh, just compare the ranges of the biggest number to the smallest number. The biggest number in B is 10, and then minus A, which is 0, and you get 10. No, it's the range of A and then B. And that's why I said we're going to understand how range works in a box plot, because this is the question I was talking about. So let's compare class A to class B. Okay, if I look at class A, I have the highest point. So we look at the lines over here and over here. If I draw a line corresponding to the number, I get it has the highest number 5 and it's the lowest number 0. So to look for the range, I do 5 minus 0, which equals 5. So I have a range in class A of 5. So now let me do B. If I do B, I have a corresponding number of 1 and a corresponding number of 10. So I'm going to do 10 minus 1, which equals 9. So I have a range of 9 for B. And we're looking for the positive difference. So I'm going to do 9 minus 5, and that's going to give you my answer of the ranges of the number of books read over the summer. So if I do 9 minus 5, I'm going to get 4, which equals the range of both class A and class B subtracting each other. Therefore, my range is indeed 4. Okay, let's look at this question. The dot plots represent the distribution of values in dataset A and dataset B. Which of the following statements must be true? So we have two statements, so we're going to call it 1 and 2 as the answer choices show. I'm given that the median dataset A is equal to the median of B. So let's count all the points, right? If we count all the points of dataset A and B, let's see. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I have 17 points of dataset A. And then for B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I'm going to have 17 as well. So my median is going to be the number 9. So let's compare the medians now. So let me count to 9 for dataset A and B and look at the medians and then compare them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a median of dataset B, of dataset A of 13. And we look at B, 1, 2, 3, 4, 5, 6, 7, 8, 9. And B, I'm going to have a median of also 13. Therefore, B and D are incorrect. Now I got to figure out if the second statement is true. So what is standard deviation? Standard deviation, as I like to call it, is just a distribution of values or scores, right? So the more spread out the numbers are, that means a higher standard deviation, and a more condensed, or more condensed is the right phrase, or closer. Standard deviation is going to be smaller. So let's compare standard deviation dataset A and dataset B in the median, right? If I look at dataset B, I only have 1 point in the middle, right? And in all the test scores are expanding out. So let me look at dataset A. In dataset A, I have 3 13s, and then I have, smaller numbers in 10 and 16 compared to dataset B. Therefore, because the numbers aren't the same in the median and in the outer layers, that means that they have different standard deviations. Therefore, C is incorrect. Therefore, my answer is A. And for those wondering, dataset A has a smaller standard deviation of dataset B because there's a lot of points in the middle of 13, and there's only 1 point of data B in 13. Therefore, the dataset of B has wider standard deviation because the values are more spread out compared to dataset A. Okay, this is the last question. Dataset A consists of the heights of 75 objects and has a mean of 25 meters. Dataset B consists of heights of 50 objects and a mean of 65 meters. Dataset C consists of heights of 125 objects from dataset A and B. What is the mean in meters of dataset C? Okay, so what we want to do is obviously figure out what is the mean of dataset C over here. But we got to understand what the information that we're given and figure out the total value of both dataset A and B in order to solve for C. So let's do that first. I'm given that dataset A has the height of 75 and has a mean of 25. So the heights, we have the heights of 75 objects. We have a total of 75 objects. We have a mean of 25. So in order to look for this value, all I have to do is just multiply 25 by 75, and I'm going to get the total value of all the heights in total, which equals 1,875. So multiply by 75 on both sides. These cancel out, which equals the total value of 1,875. So let's do dataset B now. Same thing. I'm given that it has the heights of 50 objects, so total of 50 objects used. And then we have a mean of 65. Same thing, just multiply 65 on both sides. Or multiply 50, sorry. 50 on both sides, these cancel out. If I do 65 times 50, I'm going to get 3,000. This is a huge number, actually. I'm going to get a number of 3,250. This is the total number, like the total value of all the heights together. And in dataset C, and this is a big step, so follow my lead. Data C has the heights of 125 objects, and this is where we got to look for the mean. So why is this important? Okay, we have the total value of data A and B. Notice how if I do 75 plus 50, which is the number of objects of heights used for A and B, that equals 125. Therefore, dataset C is just combining all the values of A and B together to look for dataset C. So dataset C can be just data A plus B, which equals data C. Because if we can see over here, if I do 75 plus 50, that gives me the total total heights of 125 objects. Therefore, I would want to combine the total values of A and B. So therefore, what is the total values of all the heights combined? So I'm ultimately going to do 1,875 plus 3,250 to look for the mean of C, which ultimately equals, so let me plug that into a calculator. That's going to give me 5,125 divided by 125. And I'm ultimately going to get my answer. And if you plug it into a calculator, if you do 5,125 divided by 125, you're going to get the answer of 41. So our mean for C, dataset C, is going to be 41, and that is indeed our answer. This is the last question. Thank you for watching.